Dear students, welcome to another session of live YouTube classes of Brilliant Qatar. In today's session, we are going to discuss the most probable MCQs from two important chapters of physics, moving charges and magnetism and matter. These are the two chapters that we are going to cover in this today's session. I'm expecting the kind attention from your side and quick response to each and every question. So let's directly go to the first question. Look at this. Force acting on a charge moving in a magnetic field will not depend upon. Force acting on a charge moving in a magnetic field. My dear students, you know that force on a moving charge, it is based on which topic? It is from the chapter moving charges and magnetism, and force on a moving charge is based on magnetic Lorentz force. I think all of you know the formula for magnetic Lorentz force. F is equal to, what is it? F is equal to QVB sine theta. You know the importance of this topic in this chapter. You can expect lot of questions from this. Force on a moving charge, F is equal to QVB sine theta. What is Q? It is the charge. V, velocity. B, the strength of the magnetic field. Theta is the angle between vector V and vector B. That means the direction of velocity and the direction of magnetic field. So clearly you can see that what are the factors affecting this force means. One is charge, velocity, magnetic field and the angle. So you can check. Velocity is there. Amount of charge is there. Intensity of magnetic field is also there. So look at option A. They are saying that it's mass. Is it affect the force? No. The answer is no. So the quantity which does not depend upon is what? Mass of the body. I mean mass of the charge particle. The answer for the question is option A. It's mass. So yes, I'm getting the comments. Very good. All are commented A. A is the right answer. So again I am telling you, it's a very important topic, magnetic Lorentz force. Please study the formula. F is equal to QVB sine theta. Right, I am going to the next question. Look at this. If two straight long conductors carrying current in the same direction, the magnetic force on each other will be. Please comment your answers. Force between two parallel current carrying conductors. What is the formula for force? Another important topic, force between two parallel current carrying conductors. Take two conductors. This one is carrying a current I1, another conductor which is carrying a current I2. And if these two conductors are separated by a distance r, what is the formula? You should recall the formula. F is equal to mu naught I1 I2 by 2 pi r. This is the force acting per unit length of the wire. This is the magnitude of the force. What about the direction? You know that the force direction will be attractive if the currents are in the same direction, and it is repulsive if they are in opposite direction. So in this question it is given that the currents are in the same direction, which means if the currents are in the same direction, what is the answer? The force is attractive. Yes, very good. Dhruvil, Faris, everybody is commented the right answer. Very good. The force is attractive. So please note that if currents are in the same direction, force is attractive. If currents are in opposite direction, the force is repulsive. Very easy question, but at the same time, my dear students, please note that they may ask this derivation also for a 2 mark or 3 mark question. So please study this derivation. Now I am going to the next question, question number 3. An electron executes a half circle of radius r in a magnetic field. Then the work done is, read the question carefully. An electron executes a half circle of radius r in a magnetic field. Then the work done is. Please comment your answers. Option A 0, option B pi r into EVB, option C 2 pi r into EVB, option D is EVB square. An electron executes a half a circle of radius r in a magnetic field. So let us take a magnetic field. Listen. So this is a magnetic field. You know the meaning of this cross marking. If magnetic field is represented like this, which means the field is into the plane of the board. So there is a magnetic field. You can see the direction of into the plane of the board. In this magnetic field, an electron is executing half a circle Okay, so half a circle means I can show the path of that electron something like this. So if an electron is moving like this, what is the work done? That's a question. My dear students, you know that this is which case of Lorentz force? Lorentz force, we have discussed many cases. Theta is equal to 0. Lorentz force formula I am again writing. F is equal to what? QVB sine theta. For charge to be follow a circular path, theta should be 90 degree. So if theta is 90, we get sine 90 is equal to 1. Force F is equal to what? QVB. If force is QVB, the charge follows a circular path. Here, there is a fundamental idea in physics. If a body is moving in circular path, you know that it is under the influence of, or it is due to which force? It is force due to what? Centripetal force. Centripetal force. So here we can ask a question. If an electron is moving in a circular path, who is providing the centripetal force? The answer is Lorentz force is providing the centripetal force. And what is the direction of centripetal force? Centripetal force is always towards the center. Right? So force direction is towards the center of the circle, and the charge is moving in the circular path means what is the angle between displacement of the body and the force? You can see that it is always 90 degree. Again, hope you remember, we studied that in class 11, work done by a centripetal force is always 0. Why? What is the reason for that? Because force work done formula, we know that W is equal to what? F dot S, which is Fs cos theta, where theta is the angle between force and displacement. If a body is moving in circular path, the angle between force and displacement will be always 90 degree. That means theta value is 90, cos 90 is equal to 0. So we get work as what? 0. So my dear students, please note that work done by centripetal force is 0. So here, even if it is full circle, half circle, if it is due to the centripetal force, work done will be 0. So what is our answer? The answer is option A, the work done is 0. Is it clear? Yes, I can see the right answer from many students. Very good, very good. Okay, can I go to the next? This is question number 3. Question number 4. See, this is also from which topic? It is also from Lorentz force only. We are going to the next. Yes. An electron is moving parallel to a magnetic field. Then the force experienced by it is. I think no need of any calculation. Please comment your answers. An electron is moving parallel to a magnetic field. Then the force experienced by it is. Please comment your answers. It is again based on Lorentz force. F is equal to, once again we can write F is equal to what? QVB sine theta. So if the electron is moving parallel, means what is the value of theta? Theta is equal to 0. What is sine 0? 0. Yes. So what we can see is the force will be 0 again. Many students are commenting the right answer. So easy question. Right. Next one. A current loop placed in a non-uniform magnetic field experiences. A current loop placed in a non-uniform magnetic field experiences what? A force of repulsion, a force of attraction, a torque, but not force and a torque. We had an identical question in electrostatics. Hope you remember, a current carrying loop. If this is a loop which is carrying current, a current carrying loop always behaves like a magnetic dipole, you know that. Which means when a current carrying loop is kept in a magnetic field, it is similar to a magnetic dipole is kept in a magnetic field. So a magnetic dipole is kept in a magnetic field. Yes, I can see the answers. Albert, Druvil, Reshma, Nitin, everybody is commenting the answer is D. Very good, that's the right answer. Why? Why it is experiencing force and torque? You know that if it is a uniform field, if a dipole is kept in a uniform field, it will experience only what? Torque. But it is given that it's a non-uniform field. So in a non-uniform field, it will be experiencing both force and torque. Right answer, very good. I'll be going to the next question. Okay, question number 6. Look at this. If two electron beams travel in the same direction, they will. If two electron beams travel in the same direction, they will attract each other, repel each other, nothing will happen. Both A and B are possible. Come into your answers. Two electron beams are traveling. So you can take one electron is going like this. So electron means it's a negatively charged particle, and another one is also going this way. What will happen to these electrons? That's a question. I can see both answers. Option A is there, option B is there. Attract each other and repel each other. What is the right answer? C. There is a chance of a confusion here, because we know that electrostatic force, if you have taken electrostatic force into consideration, electron and electron, what type of force? They will repel each other. But here what is happening means, electron is moving means surely it's a moving charge, it will produce a magnetic field. Another electron is moving, so electrons are moving means we can consider it as a flow of current only, right? Current is flowing, so it's just like two conductors. We can assume it's like two conductors carrying currents in the same direction. So what type of force will be there? Surely the answer is repulsion, because magnetic force, magnitude, if electron is moving quickly, the magnitude of magnetic force will be greater than, it dominates electrostatic force of repulsion. Electrostatic force is repulsive, but if currents are carrying in the same direction, what will happen? They will attract each other. It's already been discussed. So these two charges will attract each other. So which is the right answer? It is option A. Is there any doubt about it? Because this here, what is happening is the magnetic force, two conductors, you can consider this situation similar to two conductors carrying current in the same direction. So they will attract each other. It will dominate the electrostatic force of repulsion. Clear or not? So the answer is, Dhruvil is asking, can you explain again? Yes, I'll explain. Dhruvil, if you are considering these two charges are at rest, if one electron and another electron is, if they are at rest, which force is there? Only one force is there. What is that? It is electrostatic force of repulsion. But these are electron beams, they are moving in the same direction. So electrons are moving means we can consider it's like a continuous flow of electrons. Flow of electrons means surely there will be current. So you can consider it's like a current carrying conductor. This is also what? A current carrying conductor. They are carrying current in the same direction. Why we are saying they are in the same direction? Electrons are flowing in the same direction. So they will have a tendency to attract each other. Please note that this is not electrostatic force. It is because of the magnetic force electrons are in motion. I think it's clear, Dhruvil. Can I go to the next? Yes, thank you. Question number 7. Seventh one is, in a circular coil of radius r, the magnetic field at the center is proportional to. In a circular coil of radius r, the magnetic field at the center. Recall the formula. Magnetic field due to a circular coil. Very important derivation, my dear students. Probable 5-mark question from this chapter. Application of Biot-Savart's law, magnetic field due to a circular coil. What is that? If there is a coil of radius a, magnetic field at any point at a distance r on its axis, we have a formula. B is equal to, what is it? Mu naught n I a square divided by 2 into a square plus r square whole raised to 3 by 2. This is the expression for the magnetic field due to a circular coil. Actually, we don't need this formula for finding the answer for this question, because it's a special case. They are asking at the center of the coil only. At the center, R value will be 0. So you can take R is equal to 0. Center means here. So what is the result? At the center, we have a formula mu naught Ni by 2A. This is the expression for magnetic field at the center of a coil. What is A here? Radius. So the question is how B and radius are related. You can see that B is inversely proportional to the radius A. Magnetic field at the center is inversely proportional. In this question, the radius is given as R. So what we can write? B is inversely proportional to R, or it is directly proportional to 1 by R. Option C is the right answer. Yes, very good. Hafiz, Nitin, Albert. Yeah, very good. Right answer is option C. Clear? Right. So I am going to the next question. Till this everything clear, I think. Question number 8. Listen please. Force acting on a conductor of length 2 meter and carrying current 5 ampere is kept perpendicular to the magnetic field of 0.5 Tesla is direct numerical. Just recall the formula, substitute. Force acting on a current carrying conductor. What is the formula for that? Formula for force acting on a current carrying conductor is I L B sine theta. It's a special case of Lorentz force. You know that if you're taking a conductor into consideration, this is the formula for force I L B sine theta. I is the current, L is the length of the conductor, B is the magnetic field, theta is the angle between vector L and vector B. You know that. Now in this question it is given that perpendicular. So theta is 90, sine 90 is 1. So the formula will be what? I into L into B. Please comment your answers. Yes, I can see most of the students are commenting B. Let me check. I. What is I? I is 5. Length of the conductor is given as 2 meter. Magnetic field is 0.5 Tesla. So the answer is 5 Newton. Very good. Option B is the right answer. Very simple question. 5 Newton. Yes. So I think it's clear. I am going to the next question now. Question number 9. Electron enters into a uniform magnetic field at an angle of 60 degree. Its path will be, they are asking only the path. What is the nature of the path? Please comment your answers. Path. Here you need to recall all the cases. See, F is equal to QVB sine theta. If parallel or anti-parallel, if the charge particle, electron, whichever it is, if it is moving parallel or anti-parallel, it will move without any deviation. Yes or no? And we know that if theta is equal to 90 degree, the shape is what? Circular. But here the angle is 60, means the angle is between 0 and 90. Yes, I'm getting the answer. Very good. All are commenting this right answer. If theta lies between 0 and 90, you know that it will follow a helical path, which means if there is a magnetic field like this directed and if charge is moving like this, then it follows a helical path like this. Okay, so theta 60, theta 30, 45, anything in between 0 and 90, the answer is what? It follows a helical path. Yes, very good. Can I go to the next question? Question number 10. Listen, for conversion of galvanometer into ammeter, we connect. Again, a very simple question. Numerical will be there. You have to study the formula that I will tell you. So, what is the right answer? Tell me. How can you convert a galvanometer into an ammeter? We have two topics: conversion of galvanometer into an ammeter, conversion of galvanometer into a voltmeter. You should study the basics and study the formula also. Yes, tell me, comment your answers. Which is the right answer? Yes. If a galvanometer is given, you can convert this galvanometer into an ammeter by connecting, very good, by connecting a low resistance in parallel, shunt resistance, right? Low resistance in parallel, S. Okay, so which is the right answer? Low resistance in parallel means B is our right answer. Low resistance in parallel. We should connect a low resistance in parallel. Okay, at the same time, just recall voltmeter, conversion of galvanometer into a voltmeter. How can you convert? Conversion of galvanometer into a voltmeter. Yes, you can connect this galvanometer into a voltmeter by connecting a high resistance in series. High resistance in series. So my dear students, please study the values, formulas for this topic. What was S equation? Do you remember? Shunt resistance formula. Shunt resistance equation is Ig into G by I minus Ig. This is the equation for calculating S value, shunt resistance. What is Ig? Ig is the range of the given galvanometer. G is the resistance of the galvanometer. I, the range of the ammeter that we are going to design. Alright, range of the ammeter. Ig is again range of the galvanometer. So please practice the numerical based on these two, conversion of galvanometer into ammeter and voltmeter. Yes, very good. I am going to the next question now. Question number 11. Listen please. If M is magnetic moment and B is the magnetic field, then torque is given by. Direct question. You have to just recall the formula. What does magnetic moment and magnetic field is given means what is the expression for the torque? Please comment your answers. Option A, M dot B. Option B is M by B. Option C is M cross B. And option D is MB square. Very good. Right answer. Yes, many are commenting the right answer. I'm very happy with your response, which shows all of you studied this chapter very well. Yes, M cross B, direct formula. In magnetism, the torque formula is M cross B, dipole moment, cross product of magnetic dipole moment and the magnetic field at the same time. Please, in electrostatics, you can make a comparison. In electrostatics, what is the formula for torque? P cross E, identical formula, compare and study. P is sin theta in electrostatics, M B sin theta in magnetism. P is electric dipole moment, M is magnetic dipole moment. E is intensity of electric field, B is intensity of magnetic field. Easy, right? Yes. Going to question number 12. Look at this. An alpha particle and a proton travel with the same velocity in a magnetic field perpendicular to the direction of their velocities. The ratio of the radii of their circular paths. This is a bit tricky one, a numerical type. Alpha particle and a proton travel with the same velocity in a magnetic field perpendicular to the direction of their velocity. So charge is entering perpendicular to the magnetic field. So surely you can take theta is equal to what? 90 degree. The ratio of the radii of the circular path, you have to find the ratio of radius. Okay, radius of alpha particle. First particle is alpha, then proton. Do you remember the expression for the radius? If you don't remember this in exam hall, no need to worry. Please just recall the idea. Lorentz force. F is equal to what? All of you know that F is equal to QVB sin theta. I am starting with that. F is equal to QVB sin theta. Okay, this is the Lorentz force formula. Now it is given that they are entering perpendicular. Perpendicular means theta is equal to what? 90 degree. Theta 90, sin 90 is 1. So what is the result? QVB. QVB. This is Lorentz force. Now you have to think theta 90 means what happens? We already discussed that the charged particle will follow a circular path. Yes or no? Circular path. For every body to move in a circular path, it need what? Centripetal force. And I told you centripetal force. Who will provide the centripetal force? This Lorentz force only will provide the centripetal force. What is the formula for centripetal force? Basic formula is mv square by r. So we can equate because centripetal force is provided by the Lorentz force only. Centripetal force formula is mv square by r. That is provided by what? Lorentz force. So what you can do? Fc, centripetal force, is provided by the magnetic force. Centripetal force formula is mv square by r. Here m is the mass, v is what? Velocity, and r is the radius. It is provided by Lorentz force. What is the Lorentz force in this case? QVB. Actually, those who know the radius formula can directly substitute it, no problem. I am explaining it for if you have any confusion about the radius formula in exam hall, you can just recall these ideas and we can easily derive an expression for what? The radius. Okay, so VV will be cancelled. What you can see? R is equal to MV by what? QB. This is the equation for radius. Those who can by heart this, that's very good. Otherwise, you have to derive it like this. Now we will go to the question. Alpha particle and a proton. These are the two particles. Travel with the same velocity, not that. Velocity is same. So we don't need to bother about this term. Velocity is same for both the particle. And in a magnetic field, so there is no change in the magnetic field. Both the particles are moving into the same magnetic field only, so B value is also same. That means what are the factors affecting R? You can see that R depends on mass and charge. So surely we can write R is proportional to what? M by Q. In this case, it's not a general idea. In this case, it is given that velocity is same, magnetic field is same. So we no need to bother about those two terms. We are concentrating only on what? Mass and charge. Okay. Now we have to find radius ratio of alpha particle and proton. So from this equation what we can write? R of alpha will be proportional to mass of alpha by charge of alpha. Same way, radius of proton will be proportional to what? Mass of proton divided by charge of proton. We have to find the ratio of this. So R alpha by R proton will be equal to, take the ratio of this term, so we get M alpha by Q alpha divided by MP by QP, means it will be multiplied by QP by MP. That's it. We got the formula, required formula, we got it. Now we can just substitute. Here, please note that, see, in this question they did not mention what is an alpha particle, what is the relation between mass of alpha particle and that of proton. That you should keep it in your mind. What is the relation? My dear students, mass of alpha particle is 4 times the mass of a proton. It's a basic information. Similarly, charge of alpha particle is 2 times the charge of proton. Mass is 4 times and charge is 2 times. Now you can substitute here. Mass of alpha, we can write 4 times mass of proton, 4 MP, by charge of alpha, 2 times charge of proton, into Q of proton by mass of proton. Now you can cancel this. 4 by 2. 4 by 2 means 2 by 1. So what is our answer? The answer is 2 by 1. 2 is to 1. How many of you got the answer? Yes, I can see. Faris, Hafiz, yes, Dhruvil, Albert. Very good. The answer is option C. If anybody have any doubt in this question, you can ask me. I think it's clear for you. Please comment. Is it okay or not? Can I go to the next? Please comment. So the answer is 2 is to 1. Option C. Yes. Kevin, I think it's clear. Yeah. So I'll be going to the next. Look at this. Question number 13. A charge moves in a circle perpendicular to a magnetic field. The time period of revolution is independent of time period of revolution. Did we study a formula for the time period? No need to worry, we can easily find the answer. A charge moves in a circle perpendicular to a magnetic field. The time period of revolution. So again, it's a case of Lorentz force where theta is equal to 90 degree. It moves in a circular path. Okay, moves in a circular path means, what is the formula for force? F is equal to QVB. QVB. The time period of revolution is independent of. We can get a formula. We can derive a formula for what? Time period. How? Same procedure we did in the last question. We can go with the same procedure only. So let me go back to that question. Look at this here. What we got is R is equal to MV by QB. R is equal to MV by QB. I am starting with that only. R is equal to MV by QB. From this you can write V is equal to what? QBR by M. Okay, so you may think that why velocity? Why should we find velocity? Time period. What is the meaning of time period? Electron is moving, or whichever particle, a charge particle is moving in a circular path. If a body is moving in a circular path, what is the meaning of time period? Time period is the time taken by the particle to complete one revolution. Isn't it? So I'm just drawing a rough circle here. If R is the radius, the particle is starting from here and it is moving in the circular path. To complete one rotation, the time taken to complete one rotation is called what? It's time period. If it is making one complete rotation, what is the distance traveled? All of us know that distance traveled is equal to what? 2 pi r. So time period is equal to, velocity is equal to distance, or speed is equal to distance by time. So time is equal to what? What we can write? Distance by velocity. So what is the distance? Distance is 2 pi r. By velocity we got it here, qb r by what? M. R gets cancelled. Look at the expression for time period. It is 2 pi m by qb. Time period of revolution t is equal to 2 pi m by qb. You can see that time period depends on mass, it depends on charge, it depends on magnetic field. It depends on magnetic field, depends on charge, it depends on mass of the particle, but it is independent of which one? Yes. All of you commented the right answer. It is independent of what? Velocity of the particle. So time period is independent of velocity of the charged particle. Very good, very good. Okay, can I go to the next? Yes. Next is question number 14. Right? A wire of length L carrying a current I is bent in the form of a circle. The magnetic moment is. A wire of length L carrying a current I is bent in the form of a circle. We have to find what is its magnetic moment. If you have the idea, please do it quickly and comment your answers. Meanwhile, I'll explain. A wire of length L. So you can take this as a wire. The length is what? L. Carrying a current I. So this is a current carrying conductor. Okay. This is bent in the form of a circle. So we are bending it in the form of a circle. Then the magnetic moment, magnetic dipole moment. What is the formula? Magnetic moment of a current carrying coil. We know that magnetic dipole moment M is equal to what? NIA. An important equation for the magnetic dipole moment. N, number of turns. Here it is only one turn, so N is equal to 1. I, what is I? Current. It's given in this question also. The current is I. A is what? A is the area of the loop. Area of the loop means in this case we can say that A is the area of the circle. But how to find the area of the circle? Area is pi r square, so we can substitute. So M is equal to N is 1 I into pi into r square, where r is the radius. But the problem is the radius is not given in the question. Instead, length of the wire is L. Length of the wire, if you are making a circle using a wire, its circumference will be equal to the length, which means 2 pi r is the circumference, which is equal to what? L. So what we can write? R is equal to L by 2 pi. We got the radius. Now we can substitute that value here. We'll get the answer. M is equal to current is I. Pi is there, r square. What is r? L by 2 pi. Square it. L square by 2 square is 4 pi square. 1 pi will be cancelled. So look at the answer. It is I L square divided by what? 4 pi. I L square by 4 pi. Yes. How many of you got the right answer? Nitin. Yes. Albert, Hafiz, Reshma. Yes. So the answer is option C. Option C is the right answer. I L square by 4 pi. If any doubt is there, you can ask. This is the answer for the question. I L square by 4 pi. I think it's clear. So I'll be going into the next question. Question number 15. Okay, now you can see this is a question from the next chapter, magnetism and matter. In this chapter, you know that most of the topics, especially that Earth's magnetic field part and all, deleted. So it is easy for, you can easily score marks from it. The substance which can be strongly magnetized is called. Very simple. Yes, comment your answers. It's D only, right? Substance which can strongly magnetize is what? D. When we are talking about ferromagnetic substance, my dear students, not only ferromagnetic, dia, para, ferro. Please recall its examples and properties. Okay, because there will be questions based on that. So, substance which can be strongly magnetized is ferromagnetic only. Okay, next. Question number 16. When a bar is placed near a strong magnet, it is repelled. Then the material of the bar is quick. Repelled. When a bar is placed near a strong magnet, it is repelled. Which is the right answer? Yes. Correct, Albert, Trivil, Nitin. Yes. See, if this is a bar magnet, North Pole, South Pole, near to that we are going to place a bar. What we studied about magnetic substances, dia, para and ferro, is diamagnetic substance will be magnetized opposite the direction of applied field, but both para and ferro will be magnetized in the same direction of the applied field. Or in other words, in simple words, we can say that substances which are repelled when kept in a magnetic field are dia, and attracted when kept in a magnetic field are both para and ferro. And you know the difference between para and ferro. Ferro will be strongly attracted, para will be weakly attracted only. So here repulsion is possible for, out of this, only diamagnetic substance. So the right answer is option A. Simple question. Substance which is repelled is diamagnetic substance. Okay, next question number 17. Look at this. For which of the following substance the magnetic susceptibility is independent of temperature? Everything is knowledge based question only. For which of the following substance the magnetic susceptibility is independent of temperature? Susceptibility is independent of temperature. Quick. Yes. Prapti, Faris. Yeah, correct answer. Reshma, Hafis. Everybody is commenting the right answer only. 3 result. For diamagnetic substance, how does the susceptibility depends on temperature? It is independent. For para and ferro, can you comment the relation? How the temperature depends on susceptibility for paramagnetic and ferro? Your answers are correct. Independent for what? Diamagnetic. Okay, but what about for para and ferromagnetic substance? Yes, very good. It is inversely proportional. Very good. Inversely proportional to temperature for both ferro and paramagnetic, which means when temperature increases, its susceptibility decreases. Okay, so now we can go to question number 18. Look, example based. So this is the reason why I told you examples are important. You have to study at least 1 or 2 examples for all the substances. The examples of diamagnetic, paramagnetic and ferromagnetic materials are respectively. Yes. Yeah, Dhruvil, right answer for the previous question. Yes. Please comment. You have to check it in an order. The first one should be dia, second is para, and third one is ferro. Yes. Yes, yes, very good. All are commenting the right answer only. Diamagnetic substance, example, 1 or 2 example, please recall: copper, water, alcohol, antimony, right? And for paramagnetic, aluminum, chromium, liquid oxygen, ferromagnetic, iron, cobalt, nickel. So if you are checking the option, the copper for dia, aluminum for para, and iron for ferro. Yes, this is the right answer. Copper, aluminum and iron. Alright, yes. Question number 19. Relative permeability of iron is 5500. Its magnetic susceptibility is, very easy question if you can recall the formula. Relative permeability of iron is 5500. You have to find its magnetic susceptibility. Please comment your answers. What is the relation? Mu r, magnetic, relative permeability, mu r is equal to 1 plus chi. This is the relation. 1 plus chi is equal to what? Mu r. Here relative permeability of iron is given, it is 5500. Then what is susceptibility? Susceptibility means chi. So we have to find the value of chi. You can easily see that chi is equal to what? Mu r minus 1. So mu r is 5500 minus 1. So the answer is 5499. Very simple question, but you should know the formula. Okay, so in this chapter only very less number of formulas are there. One of the formula is this one, mu r, relative permeability, is equal to 1 plus chi. Okay, so the answer is option B. Okay, yes. Can I go to the next? Question number 20. Which of the following can be the susceptibility of a diamagnetic substance? Which of the following can be the susceptibility of a diamagnetic substance? Recall the property. Susceptibility. What are the properties of diamagnetic substance? Susceptibility is small and negative. Very important point. Susceptibility of a diamagnetic substance is small and negative. You know that for a paramagnetic substance it is small but it is positive. For a ferromagnetic substance it is large and positive, which means the negative value of susceptibility is possible only for what? Diamagnetic substance. So our answer is very, very simple. It is option C, because in that only you can see a negative sign. Yes, very good. Right answer, Kevin. Faris, yeah. Can I go to the next? Next is question number 21. Again an easy question. It's a graphical question. The variation of susceptibility of a paramagnetic substance with temperature is shown in paramagnetic substance. The variation of susceptibility with temperature. Yes, comment it. Which one? How does susceptibility depends on temperature for a paramagnetic substance? It is inversely proportional. So it's a very simple idea. You have to pick the graph which is showing inversely proportional. Of course, it is C only. Inversely proportional means you know that the shape of the graph will be as in option C. Okay, so the right answer is option C for this question. Okay, any doubt? No. Going to the next question number 22. The magnetic susceptibility of a paramagnetic substance at minus 73 degrees Celsius is 0.0060. Then its value at minus 173 degrees Celsius will be. This is an important question. There is chance of asking. The probability is very high. The magnetic susceptibility of a paramagnetic substance at temperature. So initial temperature is given as minus 73 degrees Celsius. If you are changing that temperature to minus 173 degrees Celsius, what will be the susceptibility? That's a question. Okay, so which relation we can use? We know that for a paramagnetic substance, susceptibility chi is inversely proportional to temperature. Inversely proportional to temperature, which means we can easily write chi 1 is inversely proportional to T1, chi 2 is inversely proportional to what? T2. Now take the ratio. What we can see that chi 2 by chi 1 will be equal to what? T1 by T2. Those who got the answer can comment. Chi 2 by chi 1 is equal to T1 by T2. So chi 2, the new susceptibility will be equal to initial temperature by final temperature into what? Chi 1. Initial susceptibility. Okay. Here, what is the initial temperature? Initial temperature is minus 73 degrees Celsius. My dear students, please don't substitute that temperature as it is, because the SI unit of temperature is Kelvin. It is not degrees Celsius. So first you have to convert that temperature into what? Kelvin. So T1 initial temperature is given as minus 73 degrees Celsius. Minus 73 degrees Celsius. It's equal to how many Kelvin? You can add with plus 273, right? Which means you will be getting 200 Kelvin. T1 is equal to what? 200 Kelvin. T2 final temperature. Final temperature is given as minus 173 degrees Celsius. We need to convert into Kelvin. Plus 273. How many Kelvin? 100 Kelvin. Clear or not? Since SI unit of temperature is Kelvin, we should convert from degrees Celsius to Kelvin. Now it is an easy question. Please do it. T1, what is T1? 200 by T2, 100. Chi 1, what is initial value? 0.0060 is chi 1 value. So it is like into 2. What is our answer? 6 into 2 is 12. So the answer is 0.01 0 point. Yes, very good. Very good, Nitin. Yes, Adil. Very good. Is it clear or not? So this is the method. So please note this. And the same result you can apply for ferromagnetic as well, because in that also susceptibility is inversely proportional to what? Temperature. Okay. Can I go to the next? Question number 23. Okay. 23. Chi1 and Chi2 are susceptibilities of a diamagnetic substance at temperature T1 Kelvin and T2 Kelvin respectively. Then it's actually, we discussed it in the previous question. Just comment it. All of you know the answer for this. Chi1 by Chi2 is equal to T2 by T1, which means, which is the right answer? Chi1 by Chi2 is equal to T2 by T1 means, yes, Chi1 T1 is equal to Chi2 T2. So the answer is option A. Easy. Okay. Can I go to the next? Next is question number 24. 24th question. Yes. A steel wire. A steel wire of length L has a magnetic moment M. It is then bent into a semicircular arc. The new magnetic moment is. That's a bit confusing question. A steel wire, it's a steel wire of length L has a magnetic moment. So that wire is having, they did not say that it's a current carrying wire. There is a steel wire. It has a magnetic moment. What is a magnetic moment? It is M, capital letter M. Now that steel wire is bent into a semicircular arc. The new magnetic moment is. So let's take, listen, let this be the steel wire. Steel wire. It has a magnetic moment of how much? M. M is the magnetic moment of this steel wire. After that, they are bending this steel wire into a semicircular wire like this. Then what is its magnetic moment? Why I am saying it is confusing means, a current carrying loop can behave like a magnetic dipole. It will have a magnetic moment. Here it is not a current carrying wire. It is just a wire. Steel. So steel can be magnetized. So this is a magnet only. You have to consider it as like a magnetic wire. Right? Its moment is what? M. What is the formula for calculating magnetic dipole moment of a bar magnet? Do you remember? You can consider it as a thin bar magnet. What is the formula for the magnetic dipole moment? It is M. Do you remember this formula? Magnetic dipole moment M is equal to small m into 2L. It is like electric dipole moment P is equal to Q into 2L. In the same way you can consider M into 2L. What is M here? M is the pole strength. So this steel wire, we can consider it is like these are the two poles. This is the pole strength. This is the strength of the other one. And what is 2L? 2L is the distance between the two poles. But in this question it is given that the length of the wire is L. So we can replace this 2L by L because length of the magnet is L. Understood? So magnetic dipole moment, look at this, I am writing it again. Magnetic dipole moment M is equal to M into L. Magnetic dipole moment of the steel wire. Now what they are doing is, it is then bent into a semicircular arc. So it is the same magnet only. That means where are the two poles? This is one pole. This is the other pole. We have to find its magnetic moment. Again, what is the formula for magnetic moment? It is the product of pole strength and distance between the poles. So what is the distance between these two poles now? It is a semicircle. So if you are taking R as the radius, we can see that the distance is 2r. So the new magnetic dipole moment will be, if I am taking it as M dash, the new magnetic dipole moment will be pole strength M into what? The distance between the two poles. What is the distance between the two poles? R plus R, which is 2r. Okay, this is the new magnetic moment. Now we have to find the value of R. How to find the value of R? Length of this wire is given as L. That only made into a semicircle. So semicircle means, you know that complete circle means what is the circumference? 2 pi r. So semicircle means this length will be equal to pi r. half of a circle. That pi r is equal to the length of the wire. So we can write here pi r is equal to what? L. So r is equal to what? L by pi. Radius is L by pi. Substitute that value for r. So what is our result? M into 2 into radius is L by pi. L by pi. Is it okay? Now look at this. What is M into L? M into L is capital M, initial dipole moment. So here there is M is there, L is there. So M into L can be replaced by capital M. So what is our result? 2 is there, and that M into L is replaced by capital M by pi. Check. Is it there or not? Yes. 2m by pi. 2m by pi. That means the answer is option B. Option B is our right answer. 2m by pi. Yes, I can see the answer from Siddharth, Dhruval. Yes, very good. I think it's clear for all of you. Is it okay? Can I go to the next? Next question is question number 25. 25. Look at this. The magnetic field at the center O of the semicircle due to each straight portion. So this is a confusing question actually. What they are asking, the magnetic field at the center O of the semicircle. So where is the center? Center is here. We have to find the magnetic field at the center O, but they are not asking the field due to the entire current carrying wire. Due to each straight portion only. What is the answer? Yes, please comment. Yes, very good. Straight portion means you can see that this point is along the line of this conductor. This is the other straight portion. Again, that point is along the line of the conductor. In Biot-Savart law itself, we got an idea. Along the length of a conductor, in the same line, the field will be 0. So, the total field will not be 0 in this figure, but the field at the center due to the straight part of the conductors will be 0. So, the answer is 0 for this question. Okay, but at the same time, like in the same question, if they're asking what is the total magnetic field at the center means, how can you find it? You can leave the straight part, only that semicircular part. What is a field due to a complete circle? Field due to a complete circle, you know that B is equal to mu naught I by 2R, where R is the radius. Mu naught and I by 2A, that formula. This is for the complete circle, but semicircle means half of this, so just multiply with half. So I get mu naught I by 4R. Mu naught I by 4R. Look, that option is there. Mu naught I by 4R is there as an option. So please don't be confused. Read the question carefully. In this question, they are asking due to straight part only. So straight part only means the answer will be 0. But at the same time, if total magnetic field they are asking, the answer will be option B, mu naught I by 4R. Is it okay? Yes. So I'm going to the next question now. Question number 26. An alpha particle moves at right angles to a uniform magnetic field of 0.5 Tesla with a speed of 5 into 10 raised to 6 meter per second. The force experienced by alpha particle is direct question. Lorentz force, direct application. Please do it quickly. F is equal to which formula we can use? Again, it is given that right angle. So theta is equal to 90 degree. So QVB. QVB. Okay, Q is charge of alpha particle. Charge of alpha particle is 2 times the charge of electron. What is it? 2 into 1.6 into 10 to the power minus 19. Into velocity is given as 5 into 10 raised to 6. Magnetic field is 0.5 Tesla. 0.5 Tesla. Okay, so what will be the result? 1.6 into 5 will become 8. 8 into 10 raised to minus 13. Yes. 8 into 10 to the power minus 13 Newton. This is the answer. Please comment your answers. 2 and 0.5 will become 1. So 1.6 into 5 will be 8. Minus 19 and 6 will become minus 13. Okay. So the answer is option B. Option B is the right answer. Clear or not? Yes. I'm going to question number 27 now. An electric charge in uniform motion produces. An electric charge in uniform motion produces what? Comment your answers. An electric field only, a magnetic field only, both electric and magnetic field, no such field at all. Okay, right answer Dhrubil, Prapti, Albert. Yes, correct answer. Yeah. So you know that an electric field at rest, if it is at rest, it will produce only what? Electric field. But a moving charge can produce magnetic field. So moving charge will produce electric field, will be there anyway. Moving charge can produce magnetic field also, which means an electric charge in uniform motion produces both electric and magnetic field. Both electric and magnetic field. Yes, very good. Right answer. Going to question number 28 now. The magnetic field induction at a distance of 4 cm from a long current carrying wire is 10 raised to minus 3 Tesla. The magnetic field induction at a distance of 12 cm from the same wire is. Read the question, understand it. Magnetic field induction, that means field intensity only, at a distance of 4 cm from a long current carrying wire is 10 raised to minus 3. So recall the formula. Magnetic field due to a straight conductor. If this is a straight conductor carrying current I, there is a point at a distance r from the conductor. What is the expression for magnetic field? B is equal to mu naught I by 2 pi r. Yes or no? Yes. This is the expression for what? Magnetic field. Now it is given that it is 10 raised to minus 3 Tesla at what distance? 4 cm. Then at a distance of 12 cm. So only length, distance is changing. So we have to check the formula. How B related to R? You can see that B is inversely proportional to R because current is same. That means B2 by B1. You can write, since they are inversely proportional, it will be R1 by R2. Okay. Then we have to find B2. B2 will be equal to, how can you write? B2 is equal to B1 into what? R1 by R2. Now you can do it very easily. What is B1? B1 is 10 raised to minus 3. R1, initial distance 4, by R2 is, so 4 by 12. 4 by 12 means 1 by 3. 1 by 3 into 10 to the power minus 3. 1 by 3 is, you know that it is 0.33 into 10 raised to minus 3. Check the options. 0.33 is not there, but 3.33 into 10 raised to minus 4 is there. Okay, so that is our right answer. Option C. 3.33 into 10 to the power minus 4 is, most of you commented it correctly. Very good, very good. Okay, so I'm going to the next question, number 29. Look at this. A wire of length L carrying current I is placed perpendicular to the magnetic induction B. The total force on the wire is, direct question. A wire of length is L carrying current I is placed perpendicular to the magnetic induction B. So what is the force formula? F is equal to ILB sin theta. Okay, perpendicular, so we can write theta 90. The answer is ILB. Option A is our right answer. Very simple question. Yes, option A. Very good. Can I go to the next? So the last question of today's session, question number 30. A solenoid of 1.5 meter length and 4 centimeter diameter possesses 10 turns per centimeter. A current of 5 ampere is flowing through it. The magnetic induction at axis inside the solenoid is, direct formula, magnetic field due to a solenoid. What is it? B is equal to mu naught N I. This is the formula. All of you know that magnetic field inside a solenoid is B equal to mu naught N I. Substitute. What is mu naught value? 4 pi into 10 to the power minus 7. 4 4 pi into 10 to the power minus 7 into n. What is small letter n? Small n represents number of turns per unit length, my dear students. Number of turns per unit length means in 1 meter. Unit length is 1 meter, it is not 1 centimeter. So in 1 meter, how many turns are there? You can see the question, it possesses 10 turns per centimeter. In 1 centimeter, 10 turns are there. Then in 1 meter, how many turns will be there? Into 100, right? So total number of turns per 1 meter will be 1000. Please note that small n is equal to 1000. 1000 means 10 raised to 3 into current. Current is how many ampere? 5 ampere. Okay, so what we get? 5 into 4 is 20. 20 pi into 10 to the power minus 4 will be there. Okay, so which is equal to 2 pi into what? 10 to the power minus 3. So I think many of you made mistake for this question. Please note that small n is representing number of turns per 1 meter. Okay. So the answer is 2 pi into 10 to the power minus 3 Tesla, which is option A. Option A is our right answer. So hope all of you understand why n is taken as 1000. It's because of we have to consider 1 meter length. Okay, right. So by this we are going to end today's session. Tomorrow another teacher with another subject. Hope your preparations are going well. All the best. See you on another day with another topic in physics. Thank you very much.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.